Are you attending SC24 in Atlanta? Lenovo invites you to visit booth 2201 on the show floor at the Georgia World Congress Center from November 17th through 22nd, 2024. In the meantime, visit lenovo.com/HPC to learn more about Lenovo's HPC solutions.
We were well positioned to be seen ahead of the curve. And so over time, ML Commons has grown. We've now got over 125 members.
Is there an overall pattern or trend that you're seeing in the totality from the benchmark results? I assume other than simply more powerful, faster.
In the case of MLPerf, the data set stays the same, so using a larger and larger system becomes ever more challenging and really stresses the ingenuity of the whole community to come up with different ways of partitioning the problem.
From Orion X in association with Inside HPC, this is the @HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hi, everyone. Welcome to the @HPC podcast. I'm Doug Black of Inside HPC with Shaheen Khan of OrionX.net. And today we have with us special guest David Kanter of ML Commons. David is a founder, board member, and the head of MLPerf for ML Commons, where he helps lead the MLPerf benchmarks. David has more than 16 years of experience in semiconductors, computing, and machine learning. He was a founder of a microprocessor and compiler startup. He was also at Aster Data Systems and has consulted for NVIDIA, Intel, KLA Applied Materials, Qualcomm, Microsoft, and others. So, David, welcome.
Pleasure to be here. Thanks for having me on the show.
Great to be with you. So, why don't we start with a quick profile of ML Commons and its mission?
Yeah, so ML Commons was started to house the MLPerf benchmark. And our mission is making AI better. And what that really means is how do we make AI faster and more capable, as many of our MLPerf benchmarks help with? How do we make it more efficient, as MLPerf Power does? As well as how do we make it safer? And so we have a new effort in AI risk and responsibility that's sort of focused on that last. And so I think all of those things are what guide ML Commons. We're a consortium, we're a partnership of industry, academia, and increasingly civil society and other folks, all really focused around the goal of making AI better for everyone.
Okay. When I looked up background information on you all, I was a little surprised the organization dates back to 2018 when there was still talk, there were still worries about another AI winter, which I think is a thing of the past now. So tell us how ML Commons kind of came into being and how large your membership, how it's grown.
Absolutely. So we started not even as ML Commons, but as MLPerf, focused around the need for industry standard, open, fair, and useful benchmarks in AI. And originally that was what brought us together. And the initial effort would become MLPerf training. And so that turned out to be, I think, in many ways, a success beyond our imagination. And in terms of the people and organizations that it really rallied together. But we knew from the very start that we needed a foundation or a consortium to really house it and act as the custodian of MLPerf. And so that is ML Commons. Now, MLPerf started in 2018, but ML Commons was formed sort of mid-2020, early 2020, actually. So I was the founding executive director, and the party that we had to kick off the launch of ML Commons was slated for the third week of March 2020, which is really much more famous for other events that went on.
Afraid so, yeah.
Yes, indeed.
So it's funny you say that there were concerns of an AI winter, because I don't think within our ranks anyone was really worried about that. But
well, clearly you had a vision for AI.
Yeah, I mean, I think we were well positioned to be seen ahead of the curve. And so over time, ML Commons has grown. we've now got over 125 members of all stripes, and it's just a fantastic.
That's excellent. David, let's take us through the benchmarks as you've organized them. I know in our pre-call, I was saying that my view of benchmarking is like trying to measure a full athlete, and you can have specific, races that they compete in, or have a decathlon, or you can have a measurement for a single muscle or a combination of muscles. And AI is everywhere. So choreographing what's being measured for what reason is all over the map. You alluded to security, you alluded to HPC. Would you just take us through the whole set and the whys and wherefores of each?
Absolutely. Yeah. So MLPerf is really a family of benchmarks, and they're all full system benchmarks in many respects. Well, MLPerf storage maybe not so much, but broadly speaking, they're a set of full system benchmarks. And if we were to start at the top, I'd say there's MLPerf training, which is the one that started it all. MLPerf HPC, which is sort of a variant of training focused on scientific problems and data sets. Then also within sort of the data center genre, MLPerf inference, and that has both a data center and an edge flavor. But those are both focused on the inference side, generally higher power. Then stepping down, we've got MLPerf mobile, which is looking at inference in the context of mobile devices. MLPerf Tiny, which is sort of inference for microcontrollers and very low power. And then sort of the two newest or three newest members of the family, I'd say MLPerf Client, which is looking at sort of for PC class systems inference. And that is slated to be released soon. I'm very excited about that. MLPerf Storage, which came out pretty recently in the second iteration. And that's a little bit of a departure in that sort of looking at training as a workload, but then trying to isolate out the storage aspect. And then sort of last to round it out is MLPerf Automotive, which is focused around how can we take the magic of MLPerf inference and bring that into the automotive context, right? Because as we all know, cars are getting much more intelligent, and the capabilities there are quite impressive. And a lot of that is powered by AI.
You also mentioned safety benchmarks. What is that about?
Yeah, so our AI risk and responsibility group, that's another part of ML Common. They're focused on how can you measure the output of AI models, so sort of quality or qualities of AI models to help us get a grasp on sort of risk and responsibility. Right? Is the model saying the things that it should? Is it not saying the things that it shouldn't? You've got a chat bot to help someone with customer service at Pepsi. It shouldn't really have an opinion about what brand of cars is best, at least up until Pepsi buys a car company. Then I would expect its loyalties to shift accordingly.
So is it more than a hallucinometer, basically?
I mean, I think hallucination is sort of one aspect of that. I'm probably not the best person to go dig into the details of the AI risk and responsibility, but I think that is potentially one aspect that might be interesting.
I see. Sounds like generally just the kind of bias that might interfere with a proper advice to the user. I think it's a great area, by the way, so I applaud you for doing that. And I think it's a very hard area.
Absolutely, yeah. I mean, and one of the things I'd say is sort of a unifying theme of all of these is when I look at ML Commons and what we do, we're really good at building, and we're really good at measuring, and we're really good at AI. And so it's sort of, I think the intersection of those three really help to capture sort of our sweet spot in some ways.
Now, how do these benchmarks get created, formulated? What is the governance model for these?
Ooh, that's a great question. So each of the benchmarks originates out of a working group. And like many open organizations, anyone can join the working groups. Our members are on 6 out of the 7 continents. Anyone in Antarctica would be welcome to join. 6 out of 7 is good, 7 out of 7 is better. And those decisions are made in the working groups through a process we like to call grudging consensus. It's not quite consensus, but we want to make sure that no one leaves with a grudge.
That's great.
Obviously, some benchmarks that you all do date back further than others, but are some, could we say, more popular or influential among the group?
I love all of my children equally.
They're all special.
But, I would say if you look at it by number of submissions, I mean, certainly, the most are in ML perf inference and then maybe training. And I'd have to think about from there. Some of them also, like ML perf client is going to be a slightly different animal and has a very different sort of submission and publication process. So it's hard to even compare. But certainly I would say ML perf training and inference are extremely popular. And I was really pleasantly surprised by ML perf storage. We got, I think, 13 or 14 submitting organizations, which is really great for the second iteration of a benchmark.
Yeah, that is great. What is the storage one measuring and how does it do that? And I'm motivated when I ask this by the question of, are the storage layout patterns and access patterns and a correlation between the kind of hardware configuration and technology and topology, are those settled enough for a benchmark to be able to be illuminating, or is it still like a fluid situation?
That's a really good question. Well, let's start at the start. So ML perf storage, the focus and the goal here, almost all of our benchmarks are formulated to answer a question. And the question is better and faster, right? And for ML perf power, of course, efficient. And we want to produce things that are fair, that are reproducible, and that are going to be useful to help buyers and sellers make decisions, as well as to help engineers design the next generation of systems. So that's kind of the goals. ML perf storage looks at the workload that is AI training and then zooms in on the loading of data that occurs prior to computation. And the need in many ways arose as, I think, even as far back as 3 or 4 years ago, I had heard reports of folks buying really large clusters of accelerators and then discovering that their storage systems actually couldn't really keep pace.
Yes.
And couldn't saturate the compute side. And so that was the first clue that, oh gosh, there's a real problem here and one that we can actually help to address. And the idea of ML perf storage is to model the data ingestion that you need to feed a given set of accelerators. And so when you look at the results, which can be a little confusing, but it's typically formulated in terms of how many accelerators are being fed and what kind of accelerator, right? Because the geometry of a given accelerator will influence how much data is in a mini batch that you need to feed in, right? And so the actual process that we're measuring is start to finish. We've got some data for a given workload, and maybe it's a 3D volume that's 1 to 200 megabytes. Maybe it's an image that's a couple hundred kilobytes. How do we feed in these batches of data off of permanent storage into the host memory of a sort of emulated compute platform? And so that's sort of what you're measuring. And then you had some really good questions digging in a little bit deeper about access patterns and so forth. And a lot of that is going to be implementation specific. For instance, TensorFlow and PyTorch, their default storage engines tend to handle data quite differently. And there are also custom storage backends for PyTorch that are different from the default. And so ultimately, how the workload expresses itself will be subject to all of that. And there is this degree of configurability there, in part because I think one of the core principles of ML perf is to not be opinionated about the right implementation.
Right.
When we started, PyTorch and TensorFlow were sort of the most common training frameworks out there, but Paddle was widely used. CNTK was a thing, MXNet. And so when you're faced with a situation like that, you have to admit that they're all perfectly viable options. And so it's sort of best left to the submitter to pick what they think is the right one.
Smarter creates cooler HPC. If you're attending SC24 in Atlanta, you can learn how. Attend Lenovo's new Innovation Forums on November 19th and 20th. Open to the public, these forums are designed to showcase Lenovo's solutions that help enable outcomes, deliver insights, and solve humanity's greatest challenges. Topics include Gen AI, liquid cooling, genomics, weather and climate, storage, and cloud service providers. Register today at bit.ly/Lenovo Forums. That's bit.ly/Lenovo Forums.
David, I have open in front of me on my laptop the storage benchmark results. And as a journalist, what I would like to see would be standings, like baseball standings or football standings. Here's number one, two. But what I'm seeing really is, let's say instead I was a buyer. I'm a purchasing person, IT manager, CIO, CTO. What I really need to do is dig into what is the issue I have, the challenge I have, the need I have, and really start to match up what the different vendors are showing us in terms of, say, number of simulated Excel, all sorts of these different factors that come into play that drives the result that they get and what is appropriate for that particular buyer. Am I on the right track here?
Yeah. So, I'm going to go pick one at random here that just to dig into, right? Yeah. So let me dive in here. So let's talk about WECA, say result 58, which shows that you can, with a single client WECA pod, you can feed 24 A100s for the 3D UNet workload, right? So now 3D UNet, to decode that, is a neural network that looks at medical volumes. I think they're of brains and then picks out the cancerous and good cells. But from the standpoint of storage, I think the key thing is that you're loading these 3D volumes that are 1 to 200 megabytes, and each batch of data is going to be some number of volume, right? And the volumes would be randomly fetched off the drive. And what this result is saying is that WECA system can saturate 24 A100 class accelerate, right? And so that's how you read it. And so it kind of gives you, and it's a very unique kind of benchmark, right? Like most storage benchmarks you've seen are probably more IOPS and gigabytes per second, right?
Yeah.
Yeah. And so this is just phrased in a slightly different way. Now, one of the reasons that it's not organized like the top 500, which is sort of a rank ordered list,
right,
is it's not clear how you compare them. And in fact, as ML Commons, we don't really want to be in the business of comparing, right? Because, again, to pick two things, I'm going to pick two adjacent things here. Submission 58 is a single client WECA system. 44 is a direct attached NVMe SSD from Micron, right? And it's not necessarily clear that those things are directly comparable and in which situations they would be, right? Now, certainly there are some situations where they are comparable, but there's many where they might not be, right? As a benchmark, MLPerf storage supports both block file and object, right? And so you've got a wide variety of implementation choices there. So you could have direct attached storage, you could have network attached storage, you could have hyper-converged storage. There's so many different options in how you do your storage. And we ultimately wanted to make a tool that would work for all of those. And being that inclusive sort of necessitates the intellectual honesty to say that you can't actually make a rank-ordered list. Also, we're a neutral playing field, so we don't really want to get into the situation of making direct comparisons ourselves.
So all of this would help explain why I get many press releases from different vendors saying they came out on top on the MLPerf benchmarks. And really what they're doing is showing a particular way that they excelled, possibly.
That's exactly right. Yeah, it's a very flexible tool. I mean, to give you an example, even in MLPerf training, where every single result is expressed in terms of time to train, and smaller is better, not all submissions are really making the same point. Like, I think there was a really lovely submission a while back that many people sort of missed the importance of it. And it was a submission using JAX, which is a newer training framework that's very easy to use for researchers. And it was really the point of the submission was that JAX as a training framework is plus very close in performance to TensorFlow. And so from a marketing standpoint, I think the point they were making is, hey, JAX is so easy to use, it's so user-friendly, but it gives you the performance of Tensor. And the name of the game was not getting the biggest, the best score and tuning it to the utmost. The name of the game was showing, hey, this is close enough, it's pretty good, and your productivity will be way better, right? And so if you were to simply look at the time to train numbers, you'd come to potentially a quite different conclusion.
Well, I mean, at the end, the real benchmark is what you use. So if you already are using JAX, then it tells you how that performs.
That's right.
Then if something else is faster, it's kind of irrelevant, right?
That's right. But on the other hand, if something else is 10x faster, yeah, that might tell you something very relevant.
That's right. That's right.
Yeah.
Well, that still kind of poses the question of what does it take to switch to it? And the switching cost comes in.
100%. And again, that's sort of the area where, organizationally, we don't have an opinion on those things, and we'll leave it to the vendors to make their best case, and we'll leave it to the buyers to sort out what they like.
That's right. That's right. A couple of other questions. Are vendors certifying these benchmarks? Like in the old days, the TPC benchmarks, and looks like they have an AI version too now. They were audited and certified, and it was part of the process. Is that a requirement here, or are they self-certified like really the HPL is?
So for anything that's published on our website, all of our benchmarks have a peer review process where when you submit the results, you and your closest and friendliest competitors, customers, researchers, etc., who also submitted, get to look at your results. And one of the cardinal rules of ML Commons is that these benchmark results should be reproducible, at least as reproducible as we can make them. And by the way, on the training side, we have submissions that are absolutely massive that have been through this process, right? So in MLPerf HPC, we had some submissions on Fugaku, which at the time was the world's number 1 or number 2 supercomputer. Some of the MLPerf training results have well over 10,000 accelerators in them. And in many cases, those have been through the peer review process, and people may have attempted to reproduce those results and make sure that it's correct as part of the submission and review process.
Got it. That's excellent. Now, with some of the benchmarks, you can vary the size of the data set to put your system in its best light. And certainly these big systems want a big problem to solve.
Yes.
Is that part of the deal? Do you have like different sizes? Well, actually, this kind of leads to a whole question about data sets. I know that you provide some data sets, and I think that sort of regulates that part and makes it apples to apples. Can we talk about just the data sets by themselves and also the varying size of them?
Sure. So on the training side, so the training benchmark is a strong scaling benchmark. And so it's actually fundamentally different than LinPack HPL or Top 500, right? And so for listeners who don't know, right, with Top 500, the problem size expands with the size of your computer. And I think you can basically pick the problem size you like. With MLPerf training, the data set is the data set, and you are training to a given accuracy target. And so that's strong scaling. So actually, with a lot of LinPack results, most people are able to get 80, 90% peak flops for whatever the size of the system is. And that should generally be manageable because it is weak scaling by increasing the size of the data set. In the case of MLPerf, the data set stays the same, so using a larger and larger system becomes ever more challenging and really stresses the ingenuity of the whole community to come up with different ways of partitioning the problem, right? So that gives rise to different data parallelism, tensor parallelism, sequence parallelism, pipeline parallelism strategies that all play a role in training. We're starting to see some of that in MLPerf inference as well. So where the performance might require multiple nodes and then how you partition it. MLPerf storage is a little bit different. That is actually a weak scaling benchmark where you increase the data set size based on the scenario that you're trying to model. And so that would have different characteristics.
Very well. I have never been a fan of that vocabulary, strong scaling, weak scaling. but I know it's a standard. And for our listeners who are like-minded with me and don't like it, you're going to have to go spend some time on Wikipedia and other articles to put your head around which one means what. And also Amdahl's law and Gustafson's law and things like that. But yeah, there are different ways of getting good performance.
Yes.
David, what does it typically cost to run these benchmarks, including equipment, personnel, time, reporting, etc.? Do you have an idea about that?
That's a good question. I mean, some of it obviously scales up with the size of the system. I don't want to hazard a guess of how much it actually costs to run MLPerf HPC on Fugaku.
Yeah.
But I think it is public what Fugaku costs.
Well, maybe we can ask, how long does it take typically to run these benchmarks?
Yeah, it varies based on the system. I think for a lot of the training benchmarks, which are probably the most expensive to run, many of them are running in an hour, some of them under a minute.
Properly. In principle, theoretically speaking, in a couple of hours, you could go run it and you're done, modulo whatever storage setup it needs.
Sure. I think one of the challenges for a lot of large systems is things like preparing the system are non-trivial, right? So clearing caches, making sure that there's no failures in the system and that they've all been cleaned up. But yeah, I mean, the runtime of the benchmarks is designed to be relatively manageable.
Well, I added another hour.
Yeah. I mean, if you were running on a really slow system, there are some benchmarks that could take hours and hours.
Yeah.
That's like if you're running MLPerf inference on a Raspberry Pi.
Right.
There we go.
Again, that is the cost and downside of providing a great deal of flexibility.
So, David, let me ask a very unfair question, possibly. Is there an overall pattern or trend that you're seeing in the totality from the benchmark results? I assume other than simply more powerful, faster performance, but are there other trends that you're seeing?
Gosh, that's a good one. I mean, I think one of the most interesting things in terms of trends is just the rate of progress we've made over time has been pretty spectacular. And I think the easiest to illustrate that with is MLPerf training because it's the oldest. And again, the first round of submission was December 2024. And I think if you look over time, there's a great graph that I have that I use in a lot of my public talks that shows sort of what's the performance of that been over time. And I superimpose that against Moore's law. And if you look at that sort of time frame, and if you make the assumption that every incremental transistor linearly adds performance, right, which may not be fair, but that's a generous assumption, right? In that same time frame, I think performance has been up by maybe 4, 5, 6x. And the MLPerf performance is up by somewhere around 50x. And so I think one of the things to me that's most interesting is what it says is that when you look at MLPerf training and all the tools that you have to attack the problem, right, that we're obviously using just so much more than just pure brute force scaling, right? We're using data sets and optimizing them, how they're sorted. There's new silicon fabrication technologies that give us the advantage of Moore's law. There's new architectures, dedicated matrix multiply units. There's software optimizations, new algorithms. There's just so much that goes into it. And I think one of the things I'd say that to me is constantly very impressive is the degree to which there's just a huge amount of ingenuity in everything's on the table for really driving this level of optimization. And so I think that's a really fun and exciting story.
Yeah. Is there any geographic pattern in terms of submissions? You mentioned Fugaku. That's kind of cool to have. And of course, most of the infrastructure vendors are based in the US. Nevertheless, how global is this?
There's a huge amount of participation in Asia and in the US, and then some in Europe and some in Africa as well. So we've got a good global balance, but I think if you were to look at the most active regions, it wouldn't be surprising.
Yeah.
By the way, David, early in our conversation, I mentioned 2018 AI winter. And as I think back on it, you're right. I think the AI winter talk, I want to say, kind of died out 2, 3, 4 years before. But did you ever, and your colleagues ever think there'd be this explosion we're seeing now? back in 2018, how AI is just be taken over and is so dominant.
Yeah, there definitely were people who were of that view for sure. Absolutely. One of the people who helped found MLPerf is a gentleman named Greg Dimos, who is actually one of the people who discovered the neural scaling laws back when he was at Baidu Research with many of the founders of Anthropic and OpenAI. And so his vision is, I think, very much in the direction that we found ourselves. I would say I was a bit surprised by the degree of uptake in ChatGPT, right? Like, again, these neural scaling laws, the general trend that more data produces ultimately, in some cases, qualitatively different results. That's been known for a long time. I've been aware of that for a while. But I think I was a little bit surprised when it became sort of common dinner table talk. And the things that I know the greatest about are semiconductors, machine learning, computer performance, energy efficiency, all of those things. I think when we started out in 2018, a lot of them were kind of niche topics, and suddenly every single one of them is in the spotlight. So it's actually been truly a delight.
Yeah, it doesn't look like it's slowing down at all, and it's just going to keep getting better and better. There is some concern about, are these AI companies making money? Are they going to run out of runway? Where's the ROI for this?
Run out
As you
of
move
data.
to the enterprise,
Yeah.
are they going to have a good ROI for the projects, etc.? But I think all of those conversations are not predicting any slowdown. They're just predicting, like, ironing out wrinkles, basically.
Yeah, I mean, I certainly hope that there won't be a slowdown. But when I look at some of the absolutely fundamental changes that have gone on in society, things like the internet, I lived through the dot-com boom and bust.
Yeah.
And that certainly could happen again. But I think the thing that's clear to me is just the impact and value and just tremendous capabilities that AI brings to the table. Like, one of the things that I was at a party and someone asked me, why do I do what I do? And first of all, it's really fun. I work with fantastic people. But then there's sort of what's the impact on society angle? And one of the points I made is that if I just look at something that I have day-to-day experience with, I am not a perfect driver. I'm pretty good, but not perfect. And the reality is that if you live in San Francisco and you have the opportunity to ride in a Waymo, it's an incredible experience. And I fully believe that things like autonomous vehicles will ultimately be safer and more efficient than human-driven vehicles, right?
Yeah.
There's plenty of humans who get DUIs. There are humans that I've gone through stop signs before because I was distracted. It happens to all of us. And to err is human. And of course, computers make mistakes too. Absolutely. But they don't get tired. They don't get angry. They don't get drunk. Every so
don't
often, they
forget.
absolutely have to be rebooted. But
Yeah.
when I think about the potential, there's tens of thousands of people who lose their lives on the road every year. If we cut that down by an order of magnitude, that would be just a tremendous gift to society.
Yeah, that's right on.
And all the autonomous vehicle vendors will get sued, but that's another problem.
Well, actually, the legal aspect of who gets sued if there is a fault
Yeah.
is very real. But I
Yeah.
think the roads will be safer if there are no human drivers at all, if it's just entirely machines.
Exactly.
And I think we
Sure.
will maybe get there someday, but it's happening. That's for sure. Yeah.
Yeah, or if nothing else, even giving computers really the ability to help out, I think could be fantastic, right?
Like
Yes.
super augmented driving.
Yeah, exactly.
Yeah.
And I mean, the reality is there's just so many things that computer and a human together are so much better than on their own.
Yeah, for
Right.
sure. Yeah.
Okay, David. So why don't we end with a question looking out ahead for ML Commons, ML Perf? What's next?
Yeah, so we've got a pretty exciting time teed up. I mean, when I look at sort of where we're growing, well, in the short term, right ahead of supercomputing 2024, we're going to release MLPerf training results. And I've already seen them. They're pretty exciting. I hope you guys will join us for the briefing or at least looking at the results. And so near term, that's one of the most exciting things. Then looking out a little bit further, the release of our MLPerf client benchmarking app, I'm pretty excited about. and then really taking us into new territory, whether it's ML-Perf automotive, the next generation of storage, or ML-Perf networking. Like, all of these are potential areas where I think we just have a fantastic opportunity to help make the world better.
So we're going to look forward to the new ML-Perf benchmarks that you mentioned, and we'll look for them at SC24. Are you doing anything special at SC24?
I hope to be there, and there's going to be both an ML-Perf Birds of a Feather session and a Future of Benchmarking Birds of a Feather session. I think they're both on Wednesday, and so if I'm there, I'd love to see anyone else who's interested in the topic.
Those are great topics. I look forward to being there with you. That's great.
Fantastic.
All right. Thank you, David. That was great.
See you guys later. Take care.
That's it for this episode of the At HPC podcast.
Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen.
The At HPC podcast is a production of OrionX in association with Inside HPC.
Thank you for listening.